Hello, everybody. I would like to go through the solution of the question 49, 52, 53 for calculus section in the course of Maths 1151 at the University of New South Wales. Now, question 49, the idea is to practice cosine hyperbolic, usually the hyperbolic functions in this section. So cosine hyperbolic 4x dx, the integral, indeterminate integral, that's what we would like to calculate. So 4x is inside of the function cosine hyperbolic. So it's a sensible thing to change a variable saying that this is something else. So 4x is equal to u is a sensible choice of the changing the variable. If we derivate both sides, we have 4 dx du. So in place of dx, we will put du over 4. So we have this integral. This is a constant. We can take it out. And we know that cosine hyperbolic u, the integral of cosine hyperbolic u, it's given to us as a sine hyperbolic u. And then you shouldn't leave your solutions in that way. You need to put back your x's back. So this should be the result that you need to present, right? Because the question is about the x's is in the variable of x. So your result that you're going to present as a conclusion should be in terms of the x, okay? B part of this question is this integral that we would like to calculate. So inside we have 3x. Let's 3x is equal to u. Sensible choice for the changing the variable. Differentiate both sides. Now, since we have boundaries in the integral, we need to look at what's happening in the boundaries when we change the variable. So when x is equal to 0, u is equal to 0. That's obvious. If x is this 1 over 3 ln 2, then we have u is equal to 3 times of that, which is just ln u. So the integral in terms of the u will be from 0 to ln u. Sine hyperbolic u, instead of the du, we will have dx over 3. And 1 over 3 is a constant, will get out. And the integral of the sine hyperbolic u is the cosine hyperbolic u. And these are the boundaries that we need to calculate next. If you put them back, we have 1 over 3 cosine ln 2 minus cosine hyperbolic 0. Cosine hyperbolic 0 is 1. Now, since this one can be done, we can do a lot more in this case. Because cosine hyperbolic x, by definition, is exponential x plus exponential minus x divided by 2. So since we have ln and exponentials are inverse to each other, they are inverse functions to each other, then we should be able to get a simpler versions of this conclusion. So by using that, we can calculate cosine hyperbolic ln u by putting that exponential ln 2 will be just 2. Exponential ln 2 inverse will be just 1 over 2. So we have 1 over 2, which is this guy here. And this will be 2, 1 over 2, and we will find 5 over 4. And we put the 5 over 4 into here. Then we will have 1 over 3, 5 over 4 minus 1, which will give us 1 over 12, which is the answer that we would like to looking for. I hope it is clear, I think. And let's move on to the next question. This is the cosine hyperbolic square x dx. We don't have the boundaries. Cosine hyperbolic x, since we like the linearity. Taking the powers, we would prefer power of 1 rather than power of 2 or 3. So I think of that way in a logical way. When you're solving a problem, what is the approach to do it? So you would like to determine the less degree in the power. So this formula does it. We can use this formula to reduce the power and make it in that version. So cosine hyperbolic square x is given by this equation. We can put this in here. So we will have 1 over 2 cosine hyperbolic 2x, 1 over 2 dx. This is a simple, very straightforward. And this one is we've done above, and we will say 2x is equal to u. And then we will say dx is equal to, will be du over u. Basically, we have 1 over 2 sine hyperbolic u, cosine hyperbolic u, and then when you integrate it, cosine hyperbolic u will be giving you sine hyperbolic u, and u is equal to 2x, and you go back. So there are some stages that, as we've done here, from here to here, it should be obvious because we've done it just before, right? This was all the practice all about. And instead of the, if you have a 2x here, instead of the 4x, as you see, that will, this power will be 1 over that. And then the cosine hyperbolic is a sine hyperbolic. The inside function is exactly the inside function. So you can formulate yourself with that version. So this is what I'm doing directly. From here to here, I'm thinking of that way. And so yeah, I have 1 over 2 here. This one is 1 over 2. I have a bracket here. The bracket is here. So 1 over 2x from coming from here, that will be 1 over 4. I just get them all together. Since I have a 4, 1 over 4 here in the denominator, I'm multiplying this one by 2. This is why I have 2x here. Just tidying up the equation. There's nothing fancy in there. Okay, and how about question 52? We would like to hyperbolic function and the inverse hyperbolic function. If you have a function and inverse of the inverse of that function should give you really the identity function. That's the idea. Identity function takes every point to itself. That is how we defined identity function. Identity function is a general term, and every x goes to itself. So we have cosine hyperbolic, sine hyperbolic inverse. For this question, I just set it up some information that's coming from, these are the formulas. We need to use those formulas in order to be able to calculate those ones. So recall sine hyperbolic inverse is that, cosine hyperbolic inverse given by that, tangent hyperbolic inverse is given by this way, and cosine hyperbolic and sine hyperbolic is that. Now, cosine hyperbolic and sine hyperbolic are inverse each other. So if you apply together, then whatever your x is, it will come out as itself. So it's an identity map. X goes to the x. So we have cosine hyperbolic and sine hyperbolic inverse. And sine hyperbolic inverse 3 to the 4, I'm using this equation here. So changing the sine hyperbolic inverse, that one. This is the equation, that one. Now, here I have 3 over 4 and 3 over 4 squared plus 1. This is 9 over 16 and plus 1. If we calculate it, will be this 16 plus 9, which is that one, which is 25 over 16. When we take the square root, it will be 5 over 4. You have 5 over 4 here and 3 over 4 here. If you add those things up, you will have 8 over 4, which is just 2. So this is just ln 2. So what you got here is really cosine hyperbolic ln 2. So cosine hyperbolic definition involves the exponentials, right? Exponentials and the logarithmic function, ln functions, are inverse functions each other. So it affects the identity map, which takes the x to the x. So this will be 2, this will be 1 over 2 over 2. Then 1 over 2 is this 1 over 2 here, 2 is here, 1 over 2 here, then you get 5 over 4. Very straightforward. Okay, sine hyperbolic, tangent hyperbolic 5 over 3. Now we are going to use tangent hyperbolic inverse x given by these equations. We are going to use this one. So 1 plus x divided by 1 minus x. When we put x is equal to 5 over 13, let's see what is the number that we are going to get. So this is what I've done here. X is equal to 5 over 13. And you just do the calculations, then you will have 3 square over 2 square. Then this tangent hyperbolic inverse 5 over 13 will be 1 over 2. This 1 over 2 is coming from here. Then this is ln, and we calculate this is as 3 square and 2 square. Now you have an ln function which has a constant term is over 1 over 2. As you know, this goes up to the power because of the ln function. This is a property of an ln function, which transforms into a square root. So squaring here and taking a square root, we will have 3. And similarly, squaring here, but taking a square root will give us 2. So this number here is just 3 over 2, ln 3 over 2. We still have the sine hyperbolic, and then we have ln 3 over 2 here. Now let's calculate that, what we have. Again, this time we are going to use the definition of sine hyperbolic in terms of the exponential. And this is an advantage because we know that exponential and the ln is the inverse functions together. And then it takes the x to the x. So this will be 3 over 2. This will be 2 over 3. And that's what I'm saying here. 1 over 2 is this one, and 3 over 2 is coming from this corner, and 2 over 3 is coming from this corner. So that's negative. 6 is the common denominator. You will have 9 minus 4 over 6, so that will give you the 5 over 12. Now, the last question that I'm going to go through the solution is the question 53. And this time I would like to calculate the derivative of these functions, dy over dx, y is equal to that, y is equal to z. And this is a sine hyperbolic function. We would like to calculate the derivative. And the formula for the sine hyperbolic inverse function derivation is given by this, 1 over square root of 1 plus u squared. Now, u here is 2x. And then du over dx will be just 2. So differentiation of this is we need to apply the chain rule because this is not a one variable. U is a function of x. So this is how we think about it. So u is a function of x, so we have a chain rule. So we will do differentiation with respect to u and then the du dx. This is chain rule. So this one will be 1 over 1 plus u squared. U is 2x. 2x squared will be 4x squared. This is why I have 4x squared here. And du dx, as we calculate here, is just 2. So that's 2. So that's our result. This is differentiation method. Now for tangent hyperbolic. Now we would like to have u not equal to 1. If u is equal to 1 here, then you have a singularity. This is not defined, so we need to emphasize that here. If you have any condition, it is important to put your conditions, whatever your conditions have. So the condition for this, only when absolute value of u is smaller than 1. We don't want 1. Either -1 or +1, this has a singularity. So you need to emphasize that. Taking the derivative of this function, we are going to use this, but we have an inside function. So this is, we will think that u is 1 over x, and du will be the differentiation of this will be -1 over x squared dx. Again, we need to apply the chain rule, tangent hyperbolic x, u with respect to the du, and then the du dx, the differentiation of the inside function. So that's the chain rule. Once we've done this, we only need to do, put things together. So this is u squared, 1 minus u squared, that's 1 minus x squared, minus du over x, we calculated it 1 minus 1 over x squared. Then we need to tidy up this expression. That will give us minus 1 over 1 minus x squared. Straightforward. So the last part of this question, cosine hyperbolic and the second. So derivation of cosine hyperbolic inverse, this is a recall, this is known formula. And u needs to be bigger than 1. In this case, this is an assumption. And otherwise, I think that, maybe the absolute value. Could you please check with your records? This could be absolute value as well, because u cannot be minus plus 1. But u, they're bigger than 1, is definitely, x, sorry. Okay, x is between 0 and pi over 2, and it satisfies this condition, so we do not touch the singularity. Okay, yeah, so inside function is the second function. And when you take the derivative of the inside function, you will have du tangent x secant of dx. Again, we need to apply the chain rule, cosine hyperbolic inverse u with respect to the du, and the inside function chain rule. So this one, by this, when u is equal to secant x, we will have 1 over square root secant square x minus 1. And then we will have du dx. We have tangent secant x dx, which is this guy. Well, here you have this one as equal to tangent x. This is coming from the disequality, because 1 plus tangent square x is equal to secant square x. If you take the square root, you have if you take this one to other side and then take the square root, you will find tangent x is equal to square root of secant square x minus 1. It means that this and these ones are equal to each other, and they simplify. They cancel each other out. Only thing that you left will be the secant x. So the result for this part will be just the secant x. That's all for this video, and thank you very much for listening. All the best.